Hi all, uh, welcome to my channel Any to Many Networks. So today I'm here with you to talk about another question that would be asked in the interview for a network engineer role. So I've been asking everybody to subscribe and like and share this channel so that people whoever attends interview for network engineer, they would be it would be useful for them for learning about this type of questions or how do you answer in those interviews. And not only I'm not explaining the answers for those questions, I'm actually showing you how does actually it works. How does it works? Any interview question that would ask in the interview, I'm actually showing you how does it actually works in the reality. And not only that, so I'm actually explaining the topics as well, because if you see, for example, I've talked about, a few concepts earlier. How does a packet flow, happens in the network from one device to another device? I showed you that. So, people would expect you should know all those. Then only you can actually explain in a clear way. So that's why I'm actually showing you. I'm coming up with a lot of, scenario based questions and then trying to explain you how does it actually works. So today my question that a lot of people actually asked me, like, how does this trace route works. And I think I have never seen a video on trace route on YouTube. How does it actually works from one end to another end? Like whenever you use this trace route utility command on any of the device in order to see how packet flow from different hops in order to reach the destination, I have never seen a video someone doing it on YouTube to actually show this. So that's why I came up with this question to explain you guys. So let's go ahead and see how this trace route works. Okay, so for that I already have prepared some topology with me. I think this topology you are familiar with, which I have used for my last video. So I'm gonna open that video here. So I think this is the one. So yeah, so I have this topology here with me. So before I go and show you how does this trace route works in reality, let me explain you what is trace route and how you can actually use this utility command, and what is the protocol that is helping behind this trace route command. So trace route is nothing but it's a program or a utility that will be used in any internal internet host, where you'll be using this traceroute command to actually see how many hops that your packet is traveling through when before it reaches the destination. So if you try to see, like, if you want to, for example, if you are in for example, if you are in Boston, and if you want to uh, see how many packets that are actually traveling to your friend who is in somewhere in California, and if you want to see how many packets that are, how many hops that you have that your packet is traversing through in order to reach that destination who is sitting over there in California. So in order to see that, we can actually use this. And also this traceroute command helps you to find the route trip time and also the delay. So these are the two best uses of this traceroute utility command that you can use in order to find how many hops that you have from source to destination, and also the round trip time delay. So I'm going to show you in reality how does it work, and how many hops, and how do you find all that. So so for that reason, I'm going to use again the simulation here. So I'm going to reset the simulation and see. So what I'm going to do here is, so before I'm gonna show you how does this work, I'm gonna explain you a little bit about traceroute, how the packet travels from one end to this end. So I'm gonna give you the brief explanation about that, and then I'll show you. So whenever you try to do a traceroute from this particular host 10.0.0.10 to this 50.0.0.10, what happens is uh, an ICMP packet. So for traceroute or ping, for both of them to work, it uses ICMP protocol. So so what happens is, it creates an ICMP packet and it puts source IP as this and the destination IP as that. And then here the main concept comes like TTL value. So first it's gonna set the value as TTL value 1, and it's gonna send that packet. And once TTL value 1 means, like, once it reaches to this particular router, so it will discard the packet. It's not going to accept it, and it's going to send a reply back saying that the you know the time is exceeded kind of message you will be getting back from this router to this PC. uh, so that means like, since you are putting like 50.0.0.10, so what happens is when you use this traceroute command, you will be sending three packets. So by default you will be sending three packets in order to find the round trip time delay. So the round trip time is nothing but the time travel for the packet uh, going to the destination and coming back, that whole time from this PC to this router, and then the coming back time, the time taken for that packet to travel from source to destination and coming back is called round trip time. So you will be finding that round trip time as again here. So basically what you would do is you will be sending three packets here, ICMP packets, and then you will be getting all those three packets back, and then it's going to calculate that round trip time. And once you finish those three packets, so the packet again, it's so once you get that packet back, you will be setting the TTL value 2, and then again you will be sending same three packets to this router. So the same you will be using the same process by setting up the TTL value by incrementing it. uh, like how many ever hops that you have over here, it doesn't matter. It's like keep incrementing the TTL value, and it's gonna it keeps sending those ICMP packets all over the topology here until you reach the destination. So every time you send ICM, ICMP packet, you will be sending three packets to each router by having the TTL value incrementing by one. So once you every router it receives, like every hop that it receives that packet, it's gonna decrease the TTL value and it's gonna send. For example, like if you set up a TTL value 2 from here to this, so what happens is when the packet receives here, it's gonna decrement by 1, and then that packet will be sent to this router. So I know like I'm explaining you in theory, and you will be like, oh, what is this guy explaining? So let me do one thing. So let me go ahead and try to ping, not ping, traceroute, and see how it works. I'll show you how it works. Then you'll be getting a clear picture on this here. So traceroute, so traceRT is the command that you'll be using in Cisco packet tracer for trying to see like how many hops that the packet is traveling from source to destination. So I'm gonna give this 50.0.0.10, and once I do this, I'm just gonna close this. See this guys here. So if you place a cursor here, this is an ICMP packet and this is an R packet. Since I have just opened this topology, so what happens is it's gonna send an R packet here in order to find the interface, because I just opened, so all the configuration would be there, but this is an initial conversation, so it's going to send an ARP request in order to find the, because this video I've already done earlier, so it's going to send an ARP request to this in order to find the MAC address of this particular interface. So then it's going to send this ICMP packet, same thing. So let's click on next and see how this ARP packet goes. This is all that you guys know. So it's going to send back. Now it received ARP reply, and now it knows the MAC address of this particular router's interface. Now it's going to send an ICMP packet. As I said, there's going to be three packets that will be sent from the PC to the router by setting up the TTL value as 1. So let's open the ICMP packet and see what are the exactly fields that are going to change when you exactly do a trace route. So here, as I said, so the TTL value is going to be 1, and if you see the source IP and destination IP is the same, which I'm trying to do. And the ICMP, this is the type. When you this is an ICMP request, so whenever you use ICMP request, it's going to be like the type value is going to be like this. So it depends. So when you click on next, you see this ICMP packet is going to be traveling from PC to the router. And if you see this here, this router did not accept. This cross mark identifies that this router did not accept, and it is sending a red packet back to the PC saying that I'm not accepting this packet, I'm discarding this packet. And once, this is also an ICMP packet if you see, and here the TTL value is 255 because it's here the TTL value is 1. So it's basically what is happening is it's sending that packet back to the PC So once it receives, that means it's a round trip time. Like the packet is going here and then it's coming back. So it calculated the round trip time, and again it's going to send an ICMP packet one more time. As I said, 3 packets is going to be sent. It's calculating the round trip time, how much time it is taking for a packet to travel from this PC to this router. So you will be calculating that. I'm going to show you how much it calculated on the PC again. So let me click on the next. So packet is going to come back. So you have received, so the packet is received. Now if I click next, so this packet says the time has exceeded. Okay, so if I click on next, then another ICMP packet is going to come up and then it's going to send to the router. Let me see that. See, this is again a new ICMP packet. You can see the color difference. Earlier it was a different one. So if you click next, same thing again. If you see the it will not accept. Yeah, and it's going to send it back, and it's going to send it back. So far 2 packets has been sent. Right now I'll open the PC and I'll show you how much round trip time that it has calculated here. So if you see here, so far see 8 milliseconds and 4 milliseconds, because I'm not clicking next, so that's why it's taking a delay. But yeah, it's since so far 2 packets have been sent and came back, so that's why it calculated 8 milliseconds and 4 milliseconds. So again, if you click next, now and one more ICMP packet is sent. See, you're getting that packet back. So 3 packets were sent. Now it find out that 10.0.0.1 is their first hop. If you go to this PC and see here, yes, 8 milliseconds, 4 milliseconds and 4 milliseconds. For 3 packets, it find out the round trip time delay, and also the first hop is 10.0.0.1. Next, so now the new ICMP packet will be sent from this PC to this router by setting the value as TTL value 2. Same thing, it's going to send 3 packets. So I'll click next, one more packet. So I'm gonna do a fast forward little bit, because you know what's gonna happen again. See, now it did not discard the packet here, it sent over here, and again this router is gonna discard, and then it's gonna send the reply packet to this PC by calculating the round trip time. You see this, guys? Like, it's gonna send back. So the PC has received the packet. Now it's gonna calculate the round trip time delay. So let me open the PC and show you how it's calculated. See, 6 milliseconds it calculated just now. Same thing is gonna send another 2 packets. See, the color has changed. 2 packets. It's gonna send. It's gonna send. It's gonna send. It's replying back. One more time it calculated. One more ICMP packet is sent. You can see the color difference over there. See this? You got a reply back. That's it. Now everything is all set. Now if you open the PC, just click on the PC and see, 6 milliseconds, 6 milliseconds, 6 milliseconds. It calculated 3 round trip time. This is by default, it's calculating like 3 packets will be sent. For each and every packet that has been sent by this host, it's calculating the round trip time delay. And again, the next hop, it found the next hop, and it is going to put this as their next hop that the packet is actually traversing through. Now again, if you click on next, because my destination is somewhere here, like if you see, I think I can't reduce more. Yes, maybe I can do this. Yeah, my server is here, my Amazon server is sitting here, and I'm reaching out, my PC is reaching out to this server here. For example, like you might say, like for example, if you open a if you want to try to reach Google server, and if you open your command prompt on your PC, and if you do a trace route and then Amazon servers or Google servers IP, you would be seeing all the hops that are actually available in between. You would be reaching, your packet is actually traversing through all the hops, and finally it reaches the destination. So that's what I'm going to show you guys here. So yeah, so let me click on next. So again, same thing, it's going to set up the TTL value as 3. So now this packet is going to reach to this router 3. See, and again the time exceeded message is going to send back to the PC, and you will be seeing it is sending the reply back. So same thing, I'm gonna little fast forward this. Again, one more new ICMP packet, so it's sending back. So that's it, 3 packets is sent. That's it, it received ICMP, and now it's going to send a new one. It's going to go to router 4 now. So that's how it calculates the round trip time delay that is taking for a packet to travel from the source to the destination. In this case, my host is reaching out to Amazon web server here. So you will be seeing all that. So again, 3 packets will be sent back, and it's gonna calculate. So I'm gonna show you, once this is all done, I'm gonna show you like how many packets were totally sent, and then you can see all the hops. See, now this is my final thing. I'm almost done. That's it. I think if I go back a little bit. Oh yeah, I think this is an ICMP packet, right? No. Yeah, this is my final ICMP packet. Oh, it's finding an ARP packet. Okay, I got it. Because this is a new one. Yeah, here you go. It's sending an ICMP final packet to this nation. All this while it tried to calculate the this server's interface MAC address. So it calculated, and now it is sending it. It's sending back. So this is finally the traceroute worked fine. So that's why it's sending the actual reply back. So just open this and see, you can see this inbound details. So it's coming from 50.0.0.10 and the destination is 10.0.0.10. So if you go to the PC and see what just happened, this star means, guys, the destination host is unreachable, because it was you just saw like it was actually calculating the ARP request time, and it took a lot of time. So that's why it is like it was not reachable at first. So that's why you got this star here, because the host was unreachable. And now if I click next, it's keep sending those packets. You see this, guys, because earlier it was calculating the ARP. uh, it was actually using ARP packet for calculating the MAC address, because it knows the destination IP address. It wants the this it wants the MAC address of that particular interface. For that reason we are doing this. So yeah, TTP. This is an ICMP, right? Yeah, you guys are seeing like a lot of packets here, because just because like I have enabled all the protocols here. That's why you're able to see a lot of packets that are going in. Internally there is some topology change, that's why this is happening. But yeah, again, if I go and I'll just reset the simulation, everything, and then now if I again go here, the trace completed, it found out the final destination is 50.0.0.10. So the ping, like the trace route got successfully, like it is able to trace all the hops that were actually able to reach. When you want to reach 50.0.0, these are the hops that are it is actually traversing through, the packet is traversing through in order to reach this destination. So if I go here and again if I do this trace RT, I'm gonna do real time. I'm not gonna do a simulation this time, because I have showed you how the packets are traveling from one end to another end. So trace route, if I do 50.0.0.10, now you guys will see the communication went very fast, because we have already set the communication here. Already the ARP request, ARP calculation is done, and all the router OSPF calculation, everything is done. All, it's like you have the topology is all set. It's a pre-configured topology. That's why it's able to do it very fast, and then you are able to see all these hops that packet was traversing through. So yeah, this is how you are able to, will be like able to trace the route that is going from a source to the destination. So whenever an interviewer would if an interviewer is asking like how does traceroute work, you can explain like, okay, it sends 3 packets by setting the TTL value as 1, and then it waits for the reply. Once it receives all the reply from the router or the hop, whoever it is sitting in between, and then you set up the TTL value as 2, and then you sends out another 3 packets. It's like you increment the TTL value 1, and then it goes on. So this TTL value is mainly helpful for preventing the loops in L3. In the network layer, if you want to prevent the loops, That's why you set up this TTL value as the, by default it is 255, but you can, set up how much ever you want. By basically you can configure that. And if you don't set up this TTL value, and if you don't have this TTL value, then the packet would be revolving around and around in the network. So that packet would be keep on revolving around this network. So that's why you have to set up the TTL value in order to prevent the loops in the network layer. So I think that's all I have, guys, today. So let me know if you have any questions. Please give me the comments in the, you know under the video. I'll get back to you. And please subscribe, share, and like this video. Thank you.